God. Michelle, how are you?
I'm fine, sir.
Good. Good. You said you're okay with simultaneous factorization, so that's what we're doing. So we are doing roots. We are doing roots of quadratic equations. Now, when we are talking about roots, the solution of general roots, you know, when we are finding general roots, that is what we use the almighty formula, if you want to use the almighty formula. So the solution of a general root is normally given by the almighty formula, which we call, it has the form of the quadratic equation of the form ax squared plus bx plus c is equal to 0. Now, when we are finding the roots of this, normally we have x is equal to, using the almighty formula, f is equal to negative b plus or minus root b squared minus 4ac. I hope we've done this formula. I've taught you how it was derived. All over 2a. I've taught you this. Now, we have something we call discriminant. The discriminant is what determines the nature of the roots. That's what determines. So this one, under the roots of quadratic equations, for instance, after solving any quadratic equation, you know, maybe x is equal to 5, x is equal to 3. Sometimes I want to know the nature of the roots of the equation. So we use something called discriminants. And the discriminant is what is able to tell the nature of the roots, whether the roots are real roots or they are repeated roots or they are so and so. We are going to learn about them. So here we are going to talk about the nature of the roots. That's what we find. That means if you, after solving this, you know that you normally get x is equal to 1, x is equal to, these are the roots. Now we are going to find the nature of the roots. Are the roots we found real roots? Are they so and so and so? So we are going to talk about this then. Yeah, Ruben, talk to me. Yeah, Ruben, your hands is up.
Sir, please, I said the spelling of the discriminant.
Okay. The discriminant is discriminant. 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 And it is denoted by D. Let me just spell it here. This discriminant. That is it. And it determines the roots of the nature of the roots. So here we are going to talk about the nature of the roots. And that is the D here. We denote the discriminant by D, capital D. So the discriminant is D. D is equal to, this is b squared minus 4ac. Minus 4ac. That is it. Do you get it now? So now the first nature of root we are going to consider, we call it the extent real root. The extent real root. The first one I'm going to consider the extent real root. Distinct real roots. Now when we say if you get any root, for you to be able to know that the roots we found are the extent real roots, then the discriminant, which is b squared, b squared minus 4ac must be greater than 0. So to be able to get that your roots are the extent real roots, then that means your discriminant, which is the b squared minus 4ac must be greater than 0. Must be greater than 0. Or that means if it is greater than 0, then simply we are trying to say that b squared must be greater than 4ac. When we bring this one here, so that is it. So to be able to get the extent real root, that means the root you found or the answer you find must be greater than 0. Must be greater than 0. I'm going to solve a typical example so that you know how it works. You know how it works. Can I please clean it? Michelle, please, are you getting what we are doing? We are finding the roots of a quadratic equation. And you know, this is the nature of a quadratic equation, or this is how a quadratic equation looks like. And this is how normally we solve it. And when we solve the x, we know that x is equal to 1, x is equal to 2, and some. And these are the roots. Now we want to know the nature of the roots of the quadratic equation. So the nature of the 1, 2 we've been finding. We want to just know the nature of it. And to know the nature of it, we are going to first group them into the various types of roots. And when you get this, what does it show? When you get this, what does it show? That's what basically we are talking about. Now the first one we are going to consider is the extent real roots. Now we are saying that before the root you get can be termed as the extent real root, the discriminant, this is the discriminant, d is equal to b squared minus 4ac, which is gotten from this side, must be greater than 0. So that is it. So if you solve the equation, when they give you the equation and you solve it and you're able to get your answers being greater than 0, then that means the root you had are the extent real roots. Be sure, please, do get it.
Yes, sir.
Good. And it normally means that the extent root normally implies that the quadratic curve, that means if you have to draw a curve of the equation you're given, intersects the x-axis twice. And so it normally means that normally when you have an extent real root, normally when you have to draw its graph, when you have to represent its graph, normally the graph looks like this. Oh. So normally when you have with that one, we are saying that it's supposed to be squared minus 4ac is supposed to be greater than this. Normally when if you have the a being less than 0, if you have, so normally you're going to have a graph like this with a Cartesian, you're going to get a graph like this. Now for instance, let's take the two roots you are going to get to be alpha and beta. So let's say the two roots you are going to get is alpha and beta. Maybe where alpha is maybe 1, beta is maybe 2, anything. But let's just denote them, let's just represent them as alpha and beta. Then we mean that normally when you get an extent real root, when you have to plot it on a graph, it's normally cut the x-axis twice. So maybe this is alpha, this is beta. And this one, normally this is true when the a is greater than 0. That means the a of the equation is greater than 0. I'm going to teach you. You know how to find the a of the equation. When you compare it to the general equation will give you, are going to find the a. When the a is greater than 0, normally this is how your graph will look like. You see that you are going to get the curve cutting the two positive x-axis or cutting the two x-axis. Now, when anytime your a is less than 0, if a is less than 0, if a is less than 0, then that means normally I'm going to get, it's still going to cut the two x-axis, but this one I'm going to get a minimum distance graph, so you're going to get something like this. So let's say this the alpha and beta are representing your two roots. So basically that is it. Now let's solve an example so that you understand or you appreciate exactly what I'm trying to teach you. Now when you have something like this, they say in 2x squared minus 3x minus 1 is equal to 0. So maybe they give you a question. So find the roots of the something, the nature of the roots of this equation. So maybe they give you 2x squared minus 3x minus 1 is equal to 0. So to be able to know, or sometimes they say prove that this is a extent real root. So to show that this one is a extent real root, we are going to get b squared We are going to use the equation b squared minus 4ac, b squared minus 4ac minus 4ac must be greater than 0 to be able to show that our roots are what? Are real, or the extent real roots. Now, we are going to compare this one to the general quadratic equation, which is ax squared plus bx plus c is equal to 0. So when you compare this one, ax squared plus bx plus c is equal to 0. When you compare it, you see that comparatively b is -3, a is 2. So here you can see that a is greater than 0. So if you want to plot a graph, in case you are plotting this graph, the graph will look something like this. So so a here is 2. So we are saying that a is equal to 2, b is equal to -3, and c is equal to -1. C is equal to -1. Michelle, please, are you getting it? Good. So you have this. Now we want to show that this is they are the extent real root. So we are going to use this equation. So the equation is b squared minus 4ac is greater than 0. So this one we have b squared is here. Our b squared, we found b to be -3. So we are going to get -3 squared. -3 squared minus 4. Our a, we had our a to be 2, and we had our c to be -1. So -1 is equal to 0. Should be greater than 0. Sorry, must be greater than 0. Must be greater than 0. So we are going to get -3 squared will give us what? 9. So -3 squared will give us 9 minus -4 into bracket 2 times -1 will be -2. So -2 times -4 will be 8. So so the whole of this will be 9 plus 8. That will be must be greater than 0. So 9 plus 8, we had 17. And 17, according to the distance, so the 17 will be our discriminant. That means the 17 represents the whole of this. So the whole of this is greater than 0. That it means that the root, the root of this equation, when we have to find the root of this equation, the root of this equation will be the extent real roots. Do you get it? Please, do you get it?
Yes, sir.
Michelle, please, do you also get it? So that means, for instance, if we found this and we had maybe x to be equal to 1, s is equal to 1, x is equal to maybe 2. I've not found it. S equal to 2. Then that means these two roots are real number. They are real roots, because when we use the formula, it showed us that the answer you're going to get, the discriminant is greater than 0, which shows that the root of this equation is real, or they are real roots. Has a real root. So let me put it that way. The equation has a real roots. Has real roots. So that is it. Please, you can copy it. And let's do the next one. Are you done? Can I erase it? Can I clear it? Can I clear it?
Yes, sir. Sir, please.
Is that I should do it? I should clean it.
Yes.
Nisha, can I clean it?
Yes, sir.
Okay. Now let's also do the other one, which you call the repeated real roots. Repeated real roots, or in other words, you can call them equal roots or equal roots. Now, here in this case, if we say the roots of the quadratic equation are equal, then we just mean that the discriminant, which is d, is equal to 0. The discriminant, which is d, is equal to 0. The discriminant, which is d, is equal to, that means the discriminant, you know, the discriminant is b squared minus 4ac is equal to 0. So when we have this, then that means the roots are 0. That is it. And now, when you have to represent it in a graph, when you have a typical b minus 4ac, 4ac is equal to 0. Normally, your graph, if a is greater than, what do you call it, 0, normally you are going to have your graph looking something like this. Your graph normally sitting on, I'm going to get your graph sitting on the x-axis. So here's y, here's x. You're going to get your graph sitting on the x-axis. However, when a is rather less than 0, you're going to have the vice versa. So you're going to get your graph being under this one, x. You're going to get something like this. That is it. So here's our x and y. So that is it. Now let's solve a typical example to show this. We are going to do all the roots and we are done for the day. And so let's see. If we have x squared minus 4x plus 4 is equal to 0. Is equal to 0. Then when we have to compare this to the general quadratic equation, a will be equal to 1, right? A will be equal to 1. Then b will be equal to -4. So here b will be equal to -4. B will be equal to -4. -4. Then c will be equal to 4. So if you want to show that this equation is a repeated real root or equal roots, then that means this will be b squared will be -4 squared, that will be 16, minus 4 into bracket, another 4 times 1. Sorry, the network. So we're getting something like a certain 16 minus 4 into bracket 4. So you realize that must be equal to 0. So you realize that the discriminant here, when you multiply, you're going to get 0 is equal to 0. So it means that the root of the equation I wrote, which is what was the equation I even wrote? X squared minus 4x plus 4 is equal to 0 are equal roots. I get it. So any root we get, so for instance, you solve this, Using the Almighty formula, you get s equal to 2, s equal to 5. And that means those roots are called equal roots. Because when you find a discriminant, you're going to get it being equal to 0. So we call this one, we term this one as, what do you call it? Repeated roots or equal roots. Please, do you get it? So it just follows that this
Sir, please, no, sir.
is that
If I get something like 5 is equal to 0, is it an equal root?
no. 5 cannot be equal to 0. 5 will be greater than 0. So that means it is not equal root. You get it?
So it must be equal to 0.
Yes. It must be equal to 0. Then you know that it means that when you get is equal to 0, it means that this root this equation has a root of has equal roots. Let me put it that way. This one has equal roots. Basically, that is what it means. You can punch your calculator and see what you get. See the answers you get. So let's do the real roots. We've done the extent real root. We've done repeated real roots, which the discriminant must be equal to 0. The first one, the extent real root must be greater than 0. Now we are doing complex roots. Real roots. Then we do complex roots. Then we are done for the day. Now for the real root, the d, if the roots are real, then it can either be the extent real root or repeated root. So normally with the real root, it's a combination of the repeated root and the extent real root. So with the real root, if the roots are real, then it can either be a extent real root or a repeated real root. And so for instance, so in this case, the discriminant, must be greater or equal to 0. So must be greater or equal to 0. So what you said, the 5 you had, then if you get 5 is equal to 0, then indirectly this one is a real root. It is greater, the 5 is greater than 0, and it can also be equal to 0. You get what I'm trying to say? So Ruben,
Yes, sir. Yes,
so
sir.
in that case, yours, the one you told me, or the one you asked was will be a extent, will be a real root. So the real root, we normally with the real root, the d is the d which is a discriminant is greater or equal to 0. It's greater or equal to 0. It's greater or equal to 0. So that is it. So that is it. So for instance, so that means that when I say d, you know d is equal to b squared minus 4ac. Minus 4ac must be greater or equal to 0. So that is it. So when you try any example, you should be able to get what you are destined. Now let's do the last one. Then the next time we know what to do. So now complex roots. With a complex root, the d must be with a complex root, the d, which is a discriminant, must be less than 0. So when we get to the negatives, must be less than 0, then it means that it's a complex root. Yes, so that means it means that b squared minus 4ac must be less than 0. So in other words, you can say that b squared is less than 4ac. So in this case, if you have to draw a graph, if a is equal to, in the equation, if a is greater than 0, then that means your graph, you're going to get a graph something like this, a graph like this. Here's x. If a is less than, so this is if a is less than, if A is less than 0. Awesome. I'm going to get the graph. When you have to draw a graph, you're going to get something like this. Now let's try an example. So when you have f5x squared minus 3x plus 1 is equal to 0. Is equal to 0. Then you know that you're going to get a to be equal to 5. We're going to get a to be equal to 5. Then we are going to get b to be equal to negative 3. And we are going to get c to be equal to 1. C to be equal to 1. Now, when we just fix it into the equation, I'm going to get negative 3 squared minus 4 into bracket 5 and 1. So you are going to get 9 minus 20, which is less than 0. So you realize that this we had negative 11, less than 0. So this shows that the roots of this what do you call it, are complex roots. Do you get it? You get it, Ruben?
Yes.
Good. Let me give you work. Can I clean it?
Yes, sir.
Okay. So for what values of p? For what values of p? Will the equation, for what values of p will the equation x squared minus 2px plus p plus 2 is equal to 0 have equal roots? For what values of p will the equation x squared minus 2px plus p plus 2 is equal to 0 have equal roots? Did you get a question? Keep it say. Have you gotten a question? Ruben.
Yes, sir. Yes, sir.
Okay, so
Yes, sir.
do it for me. That's the end of the class.